Ana, la esposa del doctor. Nothing. She said, Alma, your daughter is calling you. How come I can't hear anything?
No con nada. Espérame.
Okay, let's go ahead and get started. We're going to go through the final exam review today. Okay. So this is wrong. Let's get rid of this. Okay. In order to prepare for the final assessment, your statistical understanding, final exam, assess your statistical understanding, try the following. Okay, for number 1 and 2, consider the two normal distributions given by curve A and curve B below. Which of the following has smaller mean and which has a larger standard deviation? Well, if we look at the mean here, okay, the mean of curve A is smaller than the mean of curve B. Okay, so the mean of curve A is smaller than the mean of curve B. The standard deviation of A is also smaller than the standard deviation of B because of the width involved. Okay, so which one has a smaller mean? That would be A. Which one has larger standard deviation? That one would be B. So in this case, the answer is B. Okay. Which of the has greater total area under it? Okay. Well, they're both standard normal curves. Well, they're both normal curves, not standard. But they're going to have the same area. Okay, if you were to kind of eyeball the area here and the area here, maybe I should have done that in a different color. Okay, and the area here. Okay, those are going to have the same area. So that would be C. Okay, and so we'll put C there for that one. That's a B. Oops. That's a B for that one. Okay, for the standard normal distribution, the mean is 0 and the standard deviation is 1. So that would be C again. Which of the following is not a quantitative variable? Again, what does quantitative mean? That's a number. Okay, that's numerical. Okay, age of a car, numerical. Okay, amount of cholesterol in a chocolate bar, numerical. How tall you are is numerical. What about your zip code? Your zip code, even though it's a number, is not numerical. It is actually categorical. It's a category based on five digits. Okay. So that is not quantitative. How should you classify data from the following question? What classes are you taking this semester? Well, is that qualitative? Is that quantitative discrete? Is that quantitative continuous? Or is that none of the above? Well, it's qualitative, it's categorical, okay, which is a quality, not a quantity. Okay, so that's categorical or qualitative. So that's A. Which of the following is or not a measure of center? What does not measure? What is not a measure of center? Well, is the mean a measure of the center? Yes, it is. Okay. Is the standard deviation a measure of the center? No, it's a measure of the range or the variation. Okay, the interquartile range is also a measure of variation. What about the median? The median is a measure of center. Okay, and E, obviously not correct for that one, so this is B and C. Which of the following is or not a measure of spread? Which of the following is or not a measure of spread? Spread is, again, the variation. It's the standard deviation, okay, or the interquartile range. Which are not, okay, the percentile is not. Okay, standard deviation is, interquartile range is, the z-score is also not. So this would be B and D. Okay, which of the following statistics are not resistant to outliers? Well, which one is resistant to outliers? Well, the one that is resistant to outliers is the median. This is outlier resistant. Okay, outlier resistant is the median, so that would not be true. Okay, the mode. Okay, the mode is, and that also doesn't, that's also outlier resistant because it really doesn't matter on the outliers. The mean is not outlier resistant. That is not outlier resistant. And the standard deviation is also not outlier resistant. Since in order to calculate the mean, you have to take into account all of the data, okay, and what those values are, and the standard deviation as well. You have to calculate using all the data. And so A and D are not outlier resistant. These two are, the median is, because that's just the middle number. And the mode is just the number that occurs most often. Okay, number 9. Kim's test scores revealed that she was in the 92nd percentile. What does this mean? A, she answered 92 out of 100 questions correctly. No. Let's get rid of that one. 92 test takers scored as well as she did. Nope. Okay, 8% of the other test takers scored worse than she did. No, that would mean that she's in the 8th percentile, not the 92nd percentile. She scored as well or better than 92% of other test takers. She would be way over here at 92%, and she would have scored better than 92% of the other test takers. That is correct, D. Number 10, which of the following cannot be determined by a box plot? cannot be determined by a box plot. The range, nope, the range can. The median, think of a box plot, right? What does a box plot look like? Okay, looks like that. We might have an outlier or two. Okay. The range, no, I can definitely tell the range. Okay, I can tell the highest value and the lowest value. The median, no, median's right there. Okay, the outliers, no, there's an outlier right there. And so what is it? It's the mean. The mean cannot be determined, okay, by a box plot. The run times of a marathon runner are approximately normally distributed. Okay, there's the normal curve. The z-score for his run this week is -2. Ooh, -2. Okay, so that's mu right there, the mean. Okay, he's at -2. Which of the following statements is a correct interpretation of his z-score? This week his time was 2 minutes lower. No. Okay, this is 2 standard deviations lower, not 2 minutes lower. We don't know how fast he ran. This week his time was 2 minutes lower than his time last week. Nope. This week his time was 2 minutes lower than his average time. Nope. Okay, not 2 minutes. This week his time was 2 standard deviations lower than his average time. Well, what is mu here? Mu is his average time, right? Okay, that's mu, and we're 2 standard deviations below that, so C is correct. Okay. This week his time was 2 standard deviations lower than his time last week. No, we don't know what his time last week was, and it's not 2 standard deviations below that anyway. This week his time was 2 standard deviations lower than his best time ever. No, the answer here is C. Okay, moving on. Moving on up to top. Okay. Which of the following are another name for the second quartile? Okay, which of the following are another name for the second quartile? Okay, well, what is the second quartile? Well, second quartile, Q2. Okay, Q2 on our box plot, second quartile. Okay, Q2 also is called the median, and it's also called the 50th percentile because it's right in the middle. I'm going to go with B and E on that one. Okay, use correct notation to state the null and alternative hypotheses. The average content of drinks filled by this vending machine is different from the advertised 8 ounces. They're trying to rip me off. He's scamming me, bro. Okay. Okay, so HO, P equals 8 versus H1P is greater than 8. I don't know. I don't know if it's bigger or smaller. They don't tell me whether it's bigger or smaller, right? Okay, and here, P is a proportion. So a proportion is usually 1 to 100%, okay, or 0 to 100%, and it's usually a decimal. This P is equal to not a decimal, so I know that one's wrong right away. This P is also not equal to a decimal. No, it's not a P, it's a mu. It's an average. So use correct notation to state the null. Okay, and what are we looking for? We're looking for the different. Is it different? Is mu greater than 8? Nope. Okay, we're not going to go with that one. So I'm going to go with D here. Okay. I don't even know who you are. Are you supposed to be part of my class? If not, I'm going to kick you. Han. Oh, okay. I don't know why it came up with Mimimina. Mimiha. Oh, maybe that's your email address. Who knows? Okay, whatever. Okay, thanks. Okay. Whatever you missed, you can get on the recording on YouTube. Okay, use correct notation to state, oh, this is D. We already did that one. Boom, D. Okay. Okay, number 14. What happens to the standard error of the mean when the sample size increases? When sample size increases, right? S over the square root of n. As n gets larger, what happens to the standard error? Well, it gets smaller. So that's a B, smaller. Which of the following will reduce the margin of error? Will reduce the margin of error. Increasing the confidence level will reduce the margin of error. Increase the sample size will reduce the margin of error. Okay, increasing the population. Okay, let's look at a margin of error here. Let's look at maybe x bar plus or minus k t star, okay, times s over the square root of n. Okay, what's your margin of error? It's this here. This whole thing is your standard error. Okay, this is your margin of error, right? And we talked about margin of errors when we talk about confidence intervals. Okay, so if we look at a graph real quick, always draw a graph, always draw a picture if you can. Okay. Okay, x bar is in the middle here. X bar is in the middle. Okay, and so what's gonna reduce my margin of error? What's gonna make this thing smaller? Well, either S is gonna get smaller, S goes down, gets smaller, that will reduce it. Okay. T star gets smaller, T star gets smaller. Okay, that reduces it. Or N gets bigger. Okay, N gets bigger. Okay. Okay, so what happens if I increase the confidence level? If I take the confidence, let's say that we have a really small confidence level. Let's say that our confidence level was 0.7 or 70. Okay, that means that I'm going to have a really thin strip to work with. Okay. Now what happens if I increase that confidence level? Let's say that the confidence level then goes to 99%. That means that 99% of the data, okay, here, maybe I'll color code this. Okay, whoops, that didn't work. Okay, that means that, what is going on here? Give me the right pen. The confidence level is 99%. That means that everything for 99% goes out. Okay, so what did that do? What did increasing the confidence level do? Did that increase my margin of error, or did that decrease? No, that increased what my T star is going to be. That's going to increase. The T star is going to go from here, this is T star 1, T star of the littler one, all the way up to here, which is T star of the bigger one. Okay, so that's actually going to make things wider or increase and not decrease. So you're out of there, bro. What about increasing the sample size? Will that reduce the margin of error? Yeah, it will reduce the standard error, which we saw in the previous question, which will also reduce the margin of error. What about increasing the population? We don't care about the population because nothing that we do with a confidence interval has anything to do with the population size. It only has to do with the sample size. Population size doesn't affect it. and none of the above. So we're going to go with B on that one. I'll change the color here to B. Okay. Okay, number 16. Okay, the amount of soda contained in a can for a certain brand of soda is normally distributed with a population standard deviation of 0.1 ounces. Okay, so normally distributed. Okay, a random sample of 40 cans was selected. Okay, and the amount of soda in each can was measured. The sample mean was 12.003, so sample mean was 12.03, and the sample standard deviation was 0.08 ounces. Okay, this is 12.03 ounces. Okay, what is the appropriate distribution to use when calculating a confidence interval? Okay, confidence interval. Okay, for the true mean amount of the soda in the cans of this brand. Well, they told me that the population is normal, right? So remember, when the parent is normal, the child is normal. So if the population is normal that I'm picking this out of, then I'm going to want to go with a normal distribution and not a t distribution. And also the number of cans that we're working with is pretty large. You only use t if your number of cans would be really small, or if it's a skewed distribution. Okay, so t is out of there. It says a normal distribution because the sample mean is known. No, we don't know. That's not true. That's not the sample mean. Okay, it's a normal distribution because the population standard deviation is known. Yes, that is true. It's also the only way that you can get the population standard deviation, or what we call sigma, is to know what the population is. And here they're telling us it's normally distributed with a population standard deviation. So normally distributed with a population standard deviation, the only way you get a population standard deviation is to have a normal distribution for your population. So since those two correlate, we're going to go with D on that one. Oops, not B, dyslexic. Okay, D. Okay, number 17, the chi-square distribution is what? Well, one of them looks like this. Okay, but there's a bunch of them. Okay, there's a family of these depending upon the degrees of freedom, right? So is it symmetric? No way, Jose. Okay, and then is it skewed left? It's no, that it is not skewed left. Okay, is it skewed right? Does it have a right tail? Yes, it is skewed right. So C and D are correct. Okay. Now on the final exam, the questions are all intended for you to only give one right answer. So keep that in mind. Okay. Okay, which of the following affect the shape of the sampling distribution of the sample proportion? Okay. So sample proportion, what affects the shape of this thing? Okay. Well, for a sample proportion, for proportions, what do we use? We use a z-score, right? Why? Because for a sampling proportion, okay, when we take enough samples, we get a normal distribution. Okay. This would be mu of p, or the sampling the mean of the proportions. Okay, so what's going to affect the shape of this thing? Well, what affects a z-score? Okay, what would affect the z-score? This would be, how would I get a z-score? Well, it'd be p hat minus p all over the standard error, which is the square root of p times 1 minus p all over n. Okay, so what is going to affect the shape of the sampling distribution? Okay, the shape, well, okay, the mu of p hat, we're really going to have p hat here. So that would be the p hat or p? Let me think about this for a second. Nope, it's not p hat, it's p. Let me think about that for a second. How far away is p hat from p? Yes, that's correct. It is p, okay? So if I wanted a z-score, okay, if I want to find out where p hat was, what the z-score for p hat was, right? Then I would have to calculate out what that z-score is. Okay, but what's going to affect the shape of this thing? Okay, what's going to affect the shape of this thing? Well, what's the mean? The mean is the population proportion. What's the standard error? Let's not use z-score. Z-score is too. Okay, what's the standard error? The standard error is the square root of 1 or square root of p times 1 minus p all over n. Okay, so what are the two things that I'm using here that are defining this shape? P hat doesn't define the shape. Okay, just p and n. That's it, just p and n. The population proportion, okay, and n. And what's n? Population proportion. And n is the sample size, okay? So the population size, that doesn't matter. The sample proportion, that will give us a z-score, but the z-score is not determining the shape. That just tells us what the value of p hat is, or the sample proportion. So the sample proportion doesn't tell us the shape of this thing. Okay, only the sample size and the population proportion do. So it's A and D. Okay. Okay, if the confidence level were increased from 95 to 99, if the confidence level were increased from 95 to 99%, what would happen? The confidence interval would be wider, narrower, stay the same, or can't tell. Well, if it goes to 99%, it will be wider. The higher the confidence level, the wider or more values that you're going to capture in your interval, right? Your confidence interval is going to be a couple of numbers, say that it's like 1.05 to 2.13, right? So maybe at 95% you get that, and then it would be maybe 0.98 to, I don't know, 2.24 at 99%. It would go wider. You would capture more of them. If the sample size increased, let's think about this for a second. Okay, not the confidence level. Okay, if the sample size increased, but the sample proportion remained the same, the confidence interval would do what? Well, what's the confidence interval formula? It's p hat plus or minus z star times the square root of 1 of p, let's do that, of p times 1 minus p all over n. That's the formula for confidence interval. So if n increased, what's going to happen? My margin of error decreases. As this goes up, the margin of error will go down. because I'd be dividing by a bigger number, which means that I would be adding and subtracting less, right? You'd have, say, p hat in the middle, and I'd be going up and down by less amount. I would be adding a smaller amount and subtracting a smaller amount, and so it would get narrower. Okay, this was A, that was B. If the population size increased, the confidence interval would do what? Well, it would not change at all because none of this, oh, these are p hats. P hat, there you go. Because none of this involves population size. Okay, it's just the sample size, not population size. Okay, we care less about the population size. So it would stay the same. Okay. 22. If alpha is equal to 0.01, which of the following p-values would lead to the rejection of HO? Okay. I reject HO here. Which of the p-values would lead to the rejection of HO? Okay, well, we always want our p-value to be less than our significance level, right? So we want the p-value in this case to be less than 0.01. And if it, and so which one of these is less than 0.01? Well, certainly not A, certainly not C. Okay, what about B? I like B. B is pretty low. And what about D? No, D is not less than 0.01. Okay, so 0.02 is not less than, B is the only one that's less than 0.01. So that would lead to a rejection. If the p-value is less than 0.01, then we reject the null hypothesis. That is B. Okay, 23. A study on the alcohol content of a certain type of wine reported 95% confident and reported a 95% confidence interval for the mean alcohol content of 6.8 to 8.0 at a 5% significance level. Give the decision for testing. Okay, give the decision for testing. Okay, mu equals 7 versus mu is not equal to 7. Okay, so again, a confidence interval will give me the same information as a two-tailed test if it's not equal to. Okay, it will give me the same information. A confidence interval will give me the same information. If 7 is in between, if it's in between here, then I know that there's a possibility that the mean, what the confidence interval tells me, is that there is a 95% chance that the true population mean is between 6.8 and 8.0, that the population mean, mu, is between 6.8 and 8.0. Okay, so at a 5% significance level, which is the area of rejection, so again, I'll show you, if we have 95% confidence interval going from 6.8 to 8.0, that's the same thing as saying, as having a 5% area of rejection, okay, for a hypothesis test. So all I have to do is say, well, is 7 between, it's not there, okay, 7 is not in the middle. Is 7 between 6.8 and 8.0, and it is. Okay, it is between 6.8 and 8.0, which means I fail to reject. Okay, I cannot, I would accept, okay, that mu could be equal to 7, and I would reject that they're different because 7 falls, 7 is in between these two. It falls in between those two. So hopefully that made sense. Okay, it falls in between the two. If you were to look on a number line, 6.8 and 8.0, 7, which is our, what we're asking. What we're asking is the claim bogus or not? Is the claim that the average is equal to 7, could that be true? And I'm saying, yes, it can be true. It could be true because it falls within my confidence interval. Okay, 7 could be true. So we would not reject the claim. Okay, the empirical rule, 68, 95, 99.7 applies to what type of distributions? Uniform, discrete, normal. Normal. Must apply to normal distributions. Okay, 25. If my null hypothesis is true, and we repeatedly took random samples and conducted hypotheses, testing at the 5% significant level, then we will reject HO, okay, about what? If we repeatedly took random samples, but the hypothesis was true, the null was true. Let's go back to the previous example where mu is equal to 7. If I knew, let's say that mu was equal to 7, mu was equal to 7. Okay, that was true, right? Then, and I did a 95%, no, sorry, I did a 5% hypothesis test, okay, with a 5% significance level. It's a really bad curve. Okay, then approximately how much of the time, okay, would I reject the mean? Or would I reject the null? Okay, so HO mu is equal to 7, HA mu is not equal to 7. Well, I would reject it, okay, 5% of the time. If you have a 5% significance level, that means that your region of rejection is 5%. Okay, that's a 5% region of rejection. That's what it means to reject. Okay, to reject the null, it means that we are in that 5% region. Okay, our X bar is too skewed. Okay, so that we fall in these regions here, and so we would falsely reject only 5% of the time. Okay, there's a 5% chance that we could be wrong. There's a 95% chance that we're right, but there's a 5% chance that we are wrong. So we would reject about 5% of the time. Okay, a hypothesis test gives a p-value of 0.04. P-value of 0.04, okay. A, reject the null with alpha, right? This thing has to be less than alpha to reject the null. Okay. So we would reject the null with alpha of 0.01. Well, is 0.01, is 0.04 less than 0.01? No. Okay. We would reject HO if alpha is 0.05. Yeah, 0.05. Okay, we would reject HO with alpha equaling 0.05. Okay, we would say that the probability that HO is false is 0.04. or the probability that HO is true is 0.04. Well, we found the p-value, right? Hypothesis test gives us a p-value. Okay, so we have this p-value over here of 0.04. Okay. So 0.04. Okay. And so what would we say? We say that the probability that HO is false. Okay, HO is false. Let's think of this. Okay, so HO, we'll say again that we'll just run with a mu. Mu equals 7. HA mu is not equal to 7. Okay, which one is, if I run and get a p-value, okay, what does that p-value tell me? Okay, it tells me that 4% of the time, I have a 4% chance, okay, that HO is false. Okay, there's a 4% chance that HO is false. So I'm going to go with that one as well. Okay, D, say that the probability that HO is true is 0.04. No. Okay. So because if I have 0.04, right, that p-value comes to us from a certain z-score, and that z-score is based on my sample, right? It's x bar minus mu over, say, s over the square root of n, okay, is my z-score, which gives me my p-value. The p-value is the p-value is the probability that HO is false. The probability that HO is false. Okay. This is why we do not reject HO if it is a small p-value. Okay. The p-value is the probability that HO is false. Let me erase this, that HO is false. Okay, that HO is false. Which again means that if we have a large p-value, we do not reject, right? Okay, if we have a large p-value, we do not reject. Okay. Okay, so because that's a high probability that it's false. But if we have a low p-value, then the probability that it's false is very low, and so we fail to reject. We say that has a very low probability. And so the answers here are B and C. Okay, very low probability. Okay, 27. If the observed data are said to be statistically significant, okay, then what? Okay, then what? It means that we have enough evidence to support the rejection of the null. Okay, so is the null hypothesis supported? No, we're going to reject the null. Boom. Is the alternative hypothesis supported? Yes, we're going to reject HO in favor of HA if this is the case. If it is statistically significant, okay, then we have enough evidence to support the rejection of the null. Okay, and so the alternative is supported? Yes. The p-value of the observed data is less than the level of significance. Yes, the p-value would have to be less than alpha in order for this to be rejected. So the p-value of the observed data is less than the level of significance, that is true. The p-value is greater, no, and no. So this is G and H. Okay, let's go to these symbols here. Okay, from these symbols and expressions in the box, fill in the blanks A through M. Okay, population mean, which symbol refers to population mean? Well, how about mu? Okay, mu. I'm not going to cross it off because some of these are maybe used more than once. Okay, what's sample mean? Sample mean, that's X bar. What's the population proportion? I'm going to make this smaller. Sorry. Okay, so population mean, mu. Mu. Okay, X bar was that one. Okay, population proportion, P. Sample proportion, P hat. Sample size, N. Margin of error, margin of error. Okay. Where's the margin of error? Oh, M. Okay, M. Sometimes it's used as M. Okay, margin of error. Okay. Okay, or it has two formulas. It depends on if you're using proportions or if you're using means. Okay, proportion, the margin of error is Z star times the square root of P times 1 minus P all over N. The mean is going to be T star times S over the square root of N. So those are the formulas. None of those are there. Okay, but M is the the symbol for margin of error. Okay, sometimes it'll be written as M dot E as well. M dot E will also be margin of error. Okay, population standard deviation. What's population standard deviation? Yeah, that's sigma. Sigma. What's the sample standard deviation? Sample standard deviation. That's S, or sometimes it'll be written S sub X, like in your calculator. What's the center of the distribution of sample proportions? What's the center of the distribution of sample proportions? So here I'm going to think, okay, the center of sample proportions. Oh yeah, that's just the population proportion. That's P. Okay, that's P. That's the center of sample proportions. Okay, what's the standard deviation for the distribution of sample proportion? What's the standard deviation here? Okay, or what we would call the standard error. Okay, which one's going to give us for distribution for sample proportions? And that is this guy here. Okay, this is the square root of, okay, P times 1 minus P, okay, all over N. Okay. Okay, what's the center of the distribution of sample means? What's the center of the distribution of sample means? Well, that's just mu. Okay, so that's mu. What's the standard deviation? The standard deviation for the distribution of sample means? Well, again, that's standard error, okay, which is S over the square root of N, okay? And then what's the standard error of the sample proportion? Well, if you see standard error and sample proportion, okay, and it's not standard deviation, okay, this one, you want to think hypothesis test or Z-score, This one, you want to think confidence interval. Okay, because standard deviations go with the normal curve. Okay, but for confidence interval, we always talk in terms of the standard error. Okay, it's p hat plus or minus the margin of error for a confidence interval. Well, and that's p hat plus or minus z star times the square root of p hat times 1 minus p hat all over n. And what is this guy here? Well, that's the standard error. Okay, so you want to think in terms of confidence interval, standard error. They're not calling it a standard deviation, they're calling it a standard error. The standard deviation is always based on the population. This is always based on the population. The standard error is always based on the sample. Okay, it's always based on the sample. So when we're building a confidence interval, we actually use this guy for the standard error. So square root of p hat times 1 minus p hat all over n. Okay, for that guy. Okay. Okay, that's it for the review. At this point,
Professor, for that 28, there's some that you didn't use. Are those just wrong, or they're not applicable to?
yeah, they're just not applicable to those.
Okay.
Also, Professor, on number A, population mean, the answer sheet does the U with the long, you know, like the long one instead of the mu that you used.
Okay.
You know the U with the long stick that looks like a P, but it's. And they also use the same thing on
That's
on K.
Yeah.
So K and A, you used the M, but they're using the U with a, you know, that's a P, but not a P. You know that symbol?
Not a P?
It's a U and it's long.
Yes.
Yes.
Yeah.
The
So
third one from the top is the one they used in number A.
okay, so my mu looks like that.
Yes, but I'm talking, look at the top, there's the P, P hat, and the next one.
Yeah, I got it.
Okay, just want to make sure.
Theirs looks like this.
Yes. Just, I didn't want anybody else to be like confused.
So if I really take time to draw the Greek symbol, I mean, I could sit here for a long time to try to make it perfect. Okay, there, that's mu, that's a Greek letter mu. Okay, and this is how I write that. Okay, I just do it a little faster. And if you really want me to try to perfect that, I could sit here all day and try to do my handwriting better. But these all mean the same thing. Does that make sense?
Of course, thank you so much.
Sure. Okay, any other questions? At this point?
So
Okay.
is this pretty much how the test is going to go for Thursday?
Yeah, there'll be charts and graphs, and you're just going to be answering questions. It is all multiple choice. You may have to calculate a few things here and there, but similar format. Uh, 33 multiple choice is the structure of the exam. And it has a 180-minute time limit of 3 hours. Okay, it is scheduled for 6 o'clock on Thursday. Okay. Okay, I'll be in here to field extra questions if anybody has them. If you feel that all your questions are answered, you're free to go, and I'll see you.
For the final, how many tries do we get?
2.
Thank you.
2 tries. Yeah. Good question. Other questions? Okay. What did Patricia write here? What did you write? Make sure I answered your question. Toto would take a chance and ask if you ever allowed a student to not take their final grade, blah, blah, blah. Oh, okay. No, that's not how it works. 25% of your grade is based on your final. And that's where you are able to show your cumulative understanding and reasoning for the class. I know some high school teachers allow that, and they're just being lazy. So.
Okay, Professor. Also, I was just curious if I know you can't tell us exactly what's on the exam, but would
I can, I just won't. So.
Well, should we expect Similar's question to this that's basically asking questions of our understanding of the material, or is it more like our other tests where it's problem solving and calculating things?
There are no hypothesis tests on the exam.
Okay.
Let me take a look at it real quick. I want to bring up a hard copy because I'm not sharing the exam with everybody. I was just in the folder. Here it is. Okay. So, answer your question. Okay. You'll be asked symmetry, modes, medians, means. You'll need to be able to calculate percentages. You'll need to know what probability of something is. You'll need to know how to calculate the normal CDFs. Come out with the proper normal CDFs. A lot of questions on the content, like we went over today, but you'll need to know how to construct a confidence interval and give the right confidence interval. You'll need to calculate a test statistic. Okay, for a hypothesis test, you don't need to necessarily prove one completely outright, but you'll need to be able to calculate a test statistic. So you'll be using your calculator maybe half and half. Okay, confidence levels. Okay, that's pretty standard. Okay, there'll be some questions on scatter plots and other types of plots, histograms, and population means and population proportions. If I gave you a p-value, could you give me if I gave you a p-value, could you tell me to reject or accept the nulls? Okay, if I gave you a linear relationship for a linear regression, could you tell me, what the slope and the y-intercept represent? Okay, so things like that. So,
Much, Professor.
Yeah. Yeah. So about half and half computation and intuition of the material. Okay. Okay, other questions that you wanted answered at this point? Okay, so once you begin the exam, you will have 3 hours, well, 180 minutes. Okay. So I know that I've arranged with a few of you to take the exam earlier, but even if you start your exam 5 minutes early, that means that you'll time out if you take your exam 5 minutes early, you're going to time out 5 minutes earlier. So just keep that in mind. If it's one of those people that I coordinated to take the exam early. You won't have the whole day to take it. Okay, but for everyone who I have not designated as having, you know, a conflict, you'll be taking it at 6 o'clock on Thursday.
Do we have to log in like the previous to you and then you'll tell us it's open, or we can go straight to take the test at 6 o'clock?
You can go straight to take the test. And unless there's any issues, I'll be in here at 6 o'clock.
So you'll provide a link just in case we have to come in?
Yeah, there's already one up there in ConferZoom. So yeah, there's already a session planned from 6 to 9, but it's optional. It's only if you need clarification on something, or the test isn't working for you, or something like that. Okay.
Got it. Thank you.
Sure. Okay. And other questions? Okay. Well, you can always email me. Okay. As well. Okay. Great. Okay. So yeah, that's about it. I'm going to stop my sharing at this point. And again, if you think of anything, let me know. Yeah, sure, absolutely. Hopefully you learned something this semester. You know, I mean, with all the crisis and all the hell that's breaking loose with the pandemic and everything else, it was a very, very difficult semester for everybody involved. So I'm glad that we could transition and we could still continue you guys on your path to whatever career that you want to pursue. Okay. And I'm glad that I could support you in those dreams. Well, thank you for being part of my class. Okay, with that, I'll probably sign off at this point, unless there's anything else that you need. Okay, and you're very welcome.
Thank you, Professor. Maybe see you on Thursday.
Okay, sounds good.
Bye.
Okay. And if you want to check in and say goodbye, you're more than welcome.
Okay, thank you.